Okay, example 14. We're talking about hemophilia. And this, if you read it, it's going to tell you that it's a sex-linked recessive trait. Because we see sex-linked, we know in our genotype that that's going to include X's and Y's to represent the female and the male chromosomes. It's a recessive trait, which means that a female would need 2 recessive alleles to express hemophilia, and a male would only need 1 recessive allele to express hemophilia. So we can go ahead and start with our key, which I'm going to do up here. Okay, so it's a recessive trait and we're talking about hemophilia, so I'm going to use an H. If we have 2 dominant alleles on a female, we're going to be normal. If we have a dominant allele and a recessive allele, we're still going to be normal. Because this is a recessive trait, we would need 2 recessive alleles in order for a female to have hemophilia. For a male, if he has a dominant allele, he's going to be normal. And if he has a recessive allele, he's going to have hemophilia. Okay, so we got to figure out the genotypes of the parents, and it says a non-hemophiliac man, so a normal man whose genotype is going to be, since we already have our key, he has a dominant allele, is married to a non-hemophiliac woman, so she's going to have at least 1 dominant allele. We have to look for other information to let us know what her second allele is. And it said her father had hemophilia. So her father's genotype would be this, because that is the male genotype if you have hemophilia. Because she's a daughter, he could have only given her the X chromosome, his X chromosome. He could not have given her the Y chromosome, or else it would be a son. So he had to give her a recessive allele. So now we have the genotypes for the parents. And this is a monohybrid cross, and they want to know what is the probability of giving birth to sons that are bleeders, as well as to daughters that are bleeders. Okay, so let's just set it up, see what we get. Okay, so let's look at sons first. Remember, in order to be a son, we need an X and a Y chromosome. So these 2 are going to be our sons. Of the sons, 1 out of 2 would have hemophilia. So you could either write it as 1 out of 2, or you could write 50%, whatever you prefer. Sons with hemophilia. Okay, so now let's look at the females. These are our genotypes with 2 X chromosomes. So let's take a look and see what they represent. So both of our females, they would have a normal phenotype because you would need 2 recessive alleles to have hemophilia. So we actually have a 0 out of 2 or a 0% chance of producing a daughter with hemophilia from these particular parents. Even though it's not asked, you should go ahead to kind of think about now in preparation for your exam is what is the overall percentage of them producing a child with hemophilia. So then we take into account all 4 genotypes of the offspring that we got from our cross, and we would have a 1 out of 4 chance of producing a child, or 25% of just a child with hemophilia. So make sure you're reading what the question is actually asking for when you do your crosses.